Yeah, so want to introduce, I think we're probably good to start. It's 2 or 3.
Yeah, I think that's perfect. So we thought today would be a nice time to talk about just kind of common concurrency problems you might deal with, and I think this may be like a little bit of a, I don't know if series is the right word, but we may intersperse some sessions like this as we go forward. But essentially, the idea would be to take some just relatively common concurrency problem that you might run into on a day-to-day basis and just try to break it down a little bit, look at different tools that we have with Zio for handling it, and maybe look at a little bit of the pros and cons of those. And so for today, the problem we're going to be looking at is one about caching a single value. And I think this is one that's come up a couple times, like on the Zio Discord. And a common way it gets framed, I think, is that you have some type of auth token. And here we've even created a little case class for that. And the idea is the auth token, you get it from some service. Like I think here we're pretending it's from Slack, but it could be from whatever. And you get the auth token, and you can get one whenever you want, but there's some latency in getting it. So ideally for performance, you don't want to just get a new one with everything you do. You kind of want to get one once and use as long as you can. But the auth token also has some expiration. And so you can't use it after it's expired, because it only lasts so long. And so the problem is basically someone says, well, hey, how do I like create this thing so that it kind of gets cached, so to speak, basically, so that like all my different effects that are using things kind of get the same version as long as it's valid. And then when there's a new version to get, I get the new version. And how do I manage that? And so Kit's been fantastic here in using the service pattern and kind of creating for us a little example service so we can encapsulate the logic that in real life would be occurring on the remote server, but in this case is just going to be happening on this server or on the service, I should say. So do you want to introduce a little bit what you've done here?
Yeah, sure. Let me open up the terminal too on my screen. Okay, cool. And actually, could I get the typing ability? Let me request read write access.
Yeah, exactly. You got a request. Yeah. Yes, make it read write. Okay, there you go. You should have the ability now.
Haha, destroy. Oh, I can't even type. There's delay. Okay.
I know, there's something like delete all files on local computer.
Exactly. Oh, which one is this? Let me actually do run main. Run main caching dot main. So I'll do that.
Yeah.
I'll just run some random one that hopefully doesn't blow up. Okay, cool. Hey, look at that. Caching dot main. Will that work? Yeah, sweet. Cool. Then we just hit up. Great. So yeah, so it down here, if I summon the, we are getting a refresh token, one of our little auth token things, and we're sleeping for 0 seconds. And then we're just posting a couple of messages which show up there. And I should also reset my pretty terminal coloring, so that's scala.console. No, where am I doing messages? Down here, yes. Okay, so I'll also throw a Scala console reset in there so we don't make everything blue forever. It has to be aesthetically satisfying. Okay, I don't think I saved correctly or something. But anyway, please work. No, whatever. Okay, it does not matter. So yeah, we're posting a couple of messages. They're both blue. And it works, yay. The only thing is, if we hold on to this token for too long, if we hold on to it, I believe, for any longer than 4 seconds, which is sort of the default time to expire, it's we're speeding up time and having really short expiration times for example purposes. It fails. The post message method fails. And now we get a nice little stack trace. So yeah, on line 27 in our code, no Zio internals are here, but on line 27, we fail with invalid auth token because the token has expired. And so we don't ever want that to happen. But we also don't want to have to sort of call refresh token every time we make a message, make a call, because that's slowing us down. This should now work both times, even though we're waiting, but we're going to have to get a new token, and that's going to be slow, and we don't want to be scared. So how do we solve this problem? And maybe we could even sort of use parallelism or something. But yeah, I'll let you take it over. That's basically what our service is. It's a very simple simulator of some remote API that gives us tokens and has us use the tokens to make API requests, but the tokens could expire.
Yeah, so I think so one thing I always suggest is like your starting point should be use the existing operators from the library that they're designed for that thing. And then if for some reason there's not an operator for the exact thing you need, then start putting building blocks together. But if there's already like a specific thing for this, then use the specific thing. And so this is actually a common enough problem that there was an operator that got implemented. Let me see if I can get this to called. Ooh, what did that? Zio dot. Oh, sorry, it's actually on a certain Zio. So let me just see if I can get this to just so we can click through and see this. Oh, there we go. So it's actually a cached operator on Zio that's going to return a cached value, a cached version of this workflow. So let's just play with this first, and we'll kind of see how we use this, and then we can go on to doing things that are a little bit more custom. So what we could do here is at the beginning, we could do something like, let's call this maybe cache token. And so this is going to be Slack client dot refresh token dot cached. And I have to decide what the time to live on this is going to be. So I think we said I needed to give myself a little bit of buffer here. So let's try doing like 3 seconds here. And so the one thing to notice about this, and I just wanted to highlight even just looking at this function signature, and maybe I'll just see if I can just grab this, and I'm just going to copy this here for a sec. So if we ignore this trace thing, which is kind of an internal thing that we need to we don't need to deal with here. The one thing to notice about this is it's a Zio that returns another Zio inside of it. And normally I would tell you that if you ever have this pattern where you've got a Zio inside of a Zio, like get your like ears or get your hair up a little bit of something unusual is going on here. And either I'm intentionally doing something unusual, or maybe I'm introducing some kind of bug. And so normally if you have this Zio inside a Zio, it's a lot of times it's not what you want to do. Like someone will kind of accidentally do that, and then their program won't do what they want it to do. And what they basically need to do is they needed like a flat map somewhere instead of a map somewhere, or they need to do a flatten to kind of get that down into one thing. Because normally what we want is we want our program to run and we want to get an A, or we want to fail with an E. We don't want it kind of a program that just gives us another program. But this is actually one of those exceptions to that general guideline. And so here, what we're saying is we've got this method, and I just kind of copied it out of context here. So it was just kind of freestanding, but what it actually looks like is something like this here. And so what this says is I've got an existing program, and this is going to give me something that I can run. And when I do run it, it's going to give me a new workflow that I can run as many times as I want. And each time it's going to give me the cached version of this thing. And the reason we need this pattern of kind of the Zio within the Zio is that we need to allocate some state to take care of this caching. And depending on our implementation, that may be different things. It may be a ref and a promise. It may be a synchronized ref. Maybe we'll use STM. Maybe we'll fork fibers. We can do a lot of stuff in here. But we're going to have to do something that involves kicking off some kind of Zio workflows just to kind of create this actual cache that we're going to use. So that's what this outer Zio is taking care of for us. And then this inner Zio is the one where each time we're going to run this thing, and this is going to give us a cached version of the original thing. So when we run this the first time, it'll compute something. And then when we keep running it, as long as we're within this time to live, we're just going to get that value that's within this cached version of this function. And then after it expires, we'll recompute another version of it. So that's the way to think about this. Oh, nice. Yeah, that will prevent us from, yes, overwriting everything else we're doing. And maybe I wonder if that's one's going to screw us up as well. But that's the way to interpret that ZO within a ZO type signature. So in cases like this, where you want to kind of do some ZO workflow, it's going to return another ZO workflow, and then you may want to use that in multiple places. This can make sense, but recognize this is a more advanced pattern. So if you ever see this ZO inside a ZO, ask yourself if that's something you're intentionally doing, and if not, maybe look at what you're doing and see, oh, am I actually doing what I want to do there? But so here, that's what we want to do. And so since this is a ZO, it's returning another ZO, in our for comprehension, we need to use one of these arrows to essentially run the outer part. So this is generating the new cached version of this refresh token thing. I'm not sure why are we, let's just go all compilation. I'm not sure why we're getting a little weird with filter warning.
Oh,
maybe
yeah,
it doesn't
sure.
like the, it doesn't like the type annotation because it feels like we're doing a
I think
pattern
that's what
match.
it is, but yeah.
Yeah, I
So this is
think
basically
once
a
we get,
UIO of a token, whether or not we can add that annotation there.
exactly. And I think we can even see that if I hover over this. So this is an IO that can't, this can't fail, and it's going to return, every time I run it, it's going to return an authorization token. And the expected semantics here are that if I've got no token so far, or I've got an expired token, then I'm going to go and compute one. And that if there's one that I've previously gotten that's still within its expiration time, then I'm just going to return that one immediately, and I'm not going to hit the remote server.
And just run what we have so far real quick, because so I basically, without using the cached version, I've made it so that we're going to call it 3 times the cycle of basically get a token, post a message, and then wait 2 seconds. And we're going to do it 3 times. And really only this last time we'll have needed the refresh token, because on the server we have it currently expiring every 4 seconds. But we don't necessarily know that. So this code here is going to refresh anyway, because we don't want to play with fire. And it's a little, and it's so we're getting a refresh token each time. It's a little awkward, even though we don't have to. So now what we can do is we can basically replace the uncached version with our cache token, which has the same signature now as our original function, except now, the first time we saw that we got the refresh token 3 times in the console output. This time, if it worked correctly, we should only see getting the refresh token twice. Oh,
yeah, there's a little bit of trickiness here of
maybe it's because we cached and then we slept. So let me make this 4 seconds, maybe. I might not have saved, actually, is the problem.
Oh.
Yeah. I don't think I saved. I think 3 seconds would be. Yeah. Cool. Anyway.
So this cache thing, if like all you want to do is just kind of cache this thing, then you use the existing operator, right? Like if we've got fibers are fantastic, but if all we want to do is a bunch of things in parallel, use for each par, use collect all par, you don't need to use the fibers yourself. Like someone's already thought about like the implementation of this cached operator. And in fact, there's even a slightly fancier version of this called cached invalidate that also gives you another effect that you can run. If you want to invalidate the cache, you kind of manually determine for some reason it's invalid and you want to just invalidate it then. But since we're doing Zymposium, we won't just leave it at like, here's the cached operator and use that, but we'll kind of look a little bit more about how we might implement that and some of the things that are like going on under the hood here. So for that, we might want to think about, let's see, maybe I'll make some new object here that I'll call like utilities. And so we'll start thinking, what did that say? Boy, it's all right. And so we'll start thinking about how we might implement our own version of this cached operator. And we'll talk about a couple of different data structures we could use to help us with that. And also maybe some of the like implementation details that are under the hood here that are a little bit like maybe show some of the trade-offs we can make in implementing this, where like this cache thing makes one set of choices in how to implement this that I think are probably the good choices if you're just a library and you're implementing one thing, but we'll kind of go one level deeper and we'll see what those are and why we potentially might want to make different ones. So to start here, I think I'm gonna going to create my own version here. And just to avoid kind of any implicit class stuff right now, I'm just going to make it more work of just taking a ZO. And then we could either take this time to live, that's a duration, or we could potentially, like if we wanted to maybe make it a little different, we could maybe have like a deadline. That's like another way that we could do it that might make things a little bit different here. But here, so I'm going to have this initially return just a UIO with a ZO REA.
Given our use case, maybe it would actually be interesting to have a function from A to instant and use the result that we get to calculate its own expiration time, because we could do that.
Yeah.
Our auth token, that might be kind of convenient in this case.
Yeah. So maybe I'll call this like deadline.
Yeah.
And so we'll use this A to compute the deadline. I think that sounds fantastic, and that'll make this a little bit different than the one we're already done. Should make this a little more interesting. Okay, so right now I've just sketched out the basic signature. So we're going to take a workflow, we're going to take this deadline function, and then we're going to return a workflow within a workflow here. We'll see there's a little bit of a question of kind of when we get the environment. In this version, we kind of get the environment up front. Right now, we're getting the environment each time. We can look at that a little bit, but right now, let's just kind of get a little bit into the implementation, and then we can think about that as we go. So the first thing we might think about is, okay, what data structures do we want to use to help us out here? And maybe this is a good time for a little bit of like audience participation. What data structures can people think of that might help us solve this problem?
Oh, I'll let you know what happens in the Discord. Naveed says a ref. Ozo says kind of continuation question mark, but he said that 8 minutes ago about something else. So.
Okay, so we've got ref.
Yeah, just so far, just that. Von Chav does say that, yeah, function from A to instant does make sense. For example, the Google OAuth API returns an expiry time in its payload, although that seems to always be an hour. Yeah, unfortunately, we can only then test this once in our whole Zymposium. So we'll do it 5 seconds. But yeah, that's kind of what we've modeled here, is that the auth token contains its expiration time. Yeah. So yeah, this will fit nicely with that. So then we don't have to, we can get into a problem where if you don't calculate the timeout correctly, it can get weird. But since we're deriving it from the actual token, yeah. So I think ref is the answer that we've supplied.
Yeah. So a couple of other things we could think about. There's this thing called ref.synchronized, or in Z01 this was called ref.m. And this is a ref that lets us perform ZO effects within the update function. So if we kind of remember what we talked about before with ref, we can perform pure updates within the modify function. So we can like change the state from one thing to another, but we can't actually perform ZO effects within the update function. We can decide based on the value we see what ZO operation we want to run, and then we can run that. But we can't actually do it as part of the update. Versus this ref.synchronized, it basically builds in a semaphore, and it lets us perform ZO operations in the update function. And then other writers have to semantically block how we are updating. So it's more powerful, but if we're doing the ZO operations taking an appreciable amount of time, it's going to be slower if we have high contention. But sometimes that can be what we want.
And there's also the T-ref we got from the chat. Someone.
Yeah, exactly. Yeah, that's 100% right. The T-ref could be another solution here. And so we saw when we did our nice.
Oh, sorry,
no. I love the T-Rex. So we saw when we
There we go.
did the
I'm back.
FCM session that this could make it super easy for us to solve some of these problems. Now, one thing to note here is that the TREF is more powerful in some ways than the synchronized ref, right? It allows us to kind of combine these different ones and still have them be atomic. But it actually is more limited in a way of the only thing we can do in that update function is we can update transactional variables where we can just change the state. We can't perform ZIO operations. We can't perform ZIO operations within a transaction at all. We can use a transaction to decide what operations we want to run, like we did with the ref here, but we can't actually do it within the update function. So I think here I'm going to start by using this ref.synchronize thing because we haven't used that before, and we'll kind of look at that a little bit. And then depending on timing, we can use that to take off and look at potentially, like, could we do it with one of these other data structures? So if we've got this ref synchronize thing, then typically, like, especially if I have this like ZIO within a ZIO type signature, but a lot of times the first thing I'm going to do is I'm going to think about like allocating my state for whatever data structure I have. So a lot of times a for comprehension is a nice way to do that. And so here I could do, it's called ref.synchronized in ZIO2. And then I just do this same make thing. And so that's gonna immediately push me to say, okay, well, what am I kind of decide a little bit that I'm gonna use this ref thing, but what am I actually putting in my ref? And we might think like, okay, we've like, I guess our initial thought might be, well, the whole point of this is supposed to contain the A, so it should have an A inside it. But at least the way we've got it now, it seems like we might not have an A initially because we're going to create the state right now, but we don't have any A yet. We don't have an A until we run this thing. So maybe if we're starting with like doing the simplest possible thing, which is kind of the strategy I like to follow until I'm forced to do something more, we might say this should have a option of an A inside it. And this should be none. That even right now, we can kind of think this is leaving open a little bit of a question for us of like, what are we doing with the error case here? Like, are we going to cache the error or are we not going to cache the error? Right now, this is kind of implicitly assuming that we're not going to cache the error values, but that's one of those design decisions that we could come back to. So do I need to like rename this or something so we don't have conflicts, or okay, you're already one step ahead, you're doing the next thing?
I'm just doing something below you.
Okay.
I think it's pretty good.
Okay, so we've got this ref thing. And then if I'm doing this ZIO within a ZIO pattern, then the only thing that's a little bit unusual is that this this thing in the question marks, normally it would just be like an A, it would just be kind of just a normal like value. But here I want to return a ZIO. So the thing in my question marks should itself be a ZIO value, should be what I want to do when someone runs this inner workflow here. And so here, I might start by using this modify operator. So this is the one that lets me look at the state, and then based on the state, I get to return something I want to do or some result, as well as some updated state. So I might start with that. And then the first thing I can do probably is I'll want to just match on these two possibilities. Now, I think just looking at this, we're already starting to see that our state here is maybe not quite sufficient. Because right now, like, I mean, if I just play things I had a little bit in my head without writing the code, I can see like, okay, if I don't have any value, then I need to run this ZO workflow and I need to get a value and I need to put it inside here. And okay, great. But if I've got a value, right now, I don't really necessarily have enough information to know what to do yet, because I've got a value, but is that value expired or not? I don't really know. And if it's expired, then we need to calculate again. If it's not expired, then I can just return it immediately. So it seems like this is telling us that this original representation here was maybe too naive. That basically what we maybe need is something that's more like an A and like an instant. That's the deadline. And so then here, this could be like A and deadline. And then if I'm channeling Kit, he might now be saying, well, this is getting like a little bit complicated enough that maybe this should get wrapped in its own case class. So if I wanted to, maybe I give myself just some braces in here. Okay, well, it's gonna do it outside, so that's great too. Well, and if we wanted to, we could even like, maybe we make this something like, we could maybe embody the option in this as well. So we could do like CL trait state, and maybe this is like a value.
Oh, I'm sorry.
No, you're right. Yeah, exactly. Empty. Yeah. Okay, so now we're basically, we've got exactly the same thing, but we've hopefully cleaned it up a little bit for ourselves with this state thing. And if we wanted to, this could be out here. If we wanted to kind of hide this, we could just put this in line in like the body of this method here, because we don't really need anyone in the outside world to know about this little state thing we're using. Okay, so now it seems like we've got more of the information we need. And so now we could start to say, okay, well, if it's empty, then what I really want to do is I want to run this ZO to get an A. And then given that I've got this A, and maybe I can probably, again, if I'm channeling here, would say we should use a for comprehension to make this more readable. So we might say we want to run the ZO to get an A. Then we could say, well, the deadline is just equal to get deadline of A. And then we could yield the result, which I guess here is just the A, right? I think. Mm-hmm. Yep. And then the new state, which we need to define the new state, which I guess is just, we could just say new state equals,
I think value
state
here.
Dot value. Yeah, exactly. And then just the A and the deadline. And let's see if that compiles for us. And so we see we got a little problem here. And this problem is reflecting a little bit, maybe setting us up for this synchronized draft thing. And so if we look at this error message a little bit more, it says, well, you gave me a ZO that returns an A and a new state. But what you're supposed to return to me is just an A and a new state. And that's because right now we're using this modify operator, which is just a normal modifier, which is the one that's just like the modifier on ref that says we can only do pure updates. So the way I can fix that is I can just use the right operator. I can use a modify ZO operator. And that's the operator that's only available on the synchronized ref. If I had any ref, I could use modify, but only with a synchronized ref can I use this modify ZO thing. And now this is just going to work as written. And so let's just think a little bit about the semantics here, because I mean, beyond like saying, oh, this is wonderful, like we get to use the ZO effects, like let's just understand the trade-offs here. So what we're saying is that we're going to look at this thing, and if it's empty, we're going to run this ZO workflow to put something in it. And anyone else who at the same time is also trying to update this thing and sees that it's trying to modify this is going to have to wait until until this one has completed, because there's essentially a semaphore under the hood here that anyone who is trying to write to this ref is going to have to acquire. There's just a single permit on the semaphore. So if one person is already doing this, then everyone else is going to have to wait.
And also, this is
yeah.
sort of this is our get from the returned method. Like the get is calling it. So every access to our sort of attempt to access this cached value is essentially modifying it in some case.
Exactly.
So everything's going to block if someone's trying to just run the value, just get the cached value. But it's already being updated. They're going to wait for that, right?
Exactly. And so I guess this idea of like this can either, we can either think of this as a feature or a bug, right? We could say, well, that sucks. So we want more concurrent updates going on, and we don't want to have to make people wait for each other. But here, like I think at least as this problem was posed to me recently, this was kind of like the desired feature of like, we want to wait until the new auth token's available. That's kind of the point of this exercise. And so that's why this can be a nice pattern here that we say like, okay, we want to wait for the value to be available. So this is kind of easy case if this is empty. And then we could have this other case where there's already something in here. And so here, we basically have two cases. So we could say, well, I think first we're actually going to need to get the current time. So we could say, clock.instant now. And then we basically have two cases, right? We can say if now dot is before the deadline. And one thing we may want to think about here is, and maybe this will just going to be a concern the implementer has to have, but like probably we don't want the deadline to be like literally the actual deadline down to the millisecond, because once we get this value, we're going to then make a call based on it. And if it's going to expire 1 nanosecond from now, it's probably going to blow up by the time it gets to the server. But we'll kind of, maybe we'll leave that aside for now. And that can be a concern for like the caller of like, they should build in the buffer here.
I think that makes sense because then they're flexible. They can know like
exactly
what it has to be anyway.
Right. Yep. So, okay, so we're going to get the time, and we're going to say if we're before the deadline, we're going to do one thing, and otherwise we're going to do something else. And so if we're before the deadline, then our situation is super easy, because then we can basically just succeed with the value we got, and we don't need to change the state at all. So if I wanted to, I don't know if people have seen this before, you can use this @ symbol before to just bind this value here to a new name. And that way I could just do state instead of redoing the state.value a deadline. And then here, I basically want to just take the logic from here. And actually, other than the fact that maybe this debug statement is going to be different, this logic is going to be the same. And so maybe initially I'm just going to copy this, but what I could really do if I want to be like a little bit maybe better is I could extract this into its own method here. And maybe we can show that here.
We can probably do it even here, I believe, because it's just a zero is a value, luckily. So we could even just do.
Sure.
Maybe that's a little strange, but it's it works.
Yeah, we could put it here, or we could have given ourselves some braces here, and we could just define like a def compute or something. Okay, so we've got, I think, a relatively like simple implementation here. We saw there was a little bit of a question about our error handling here. One other design choice that we made here that's worth calling out, and maybe we could explore the alternative, is this is a little bit of a what we could call like a lazy caching, right? If this is saying we're not going to compute this auth token until, or this A, whatever this A is in this case, until someone asks us for it. And then we're going to compute it, and then we're going to give the result to everyone until it expires. And then if someone asks for it and it's expired, then we're going to go and compute it again. So you could think of that as the, like I said, the lazy solution to caching of we're only going to go and get one of these values when a user asks us for it. And so the advantage of that is obviously we never just do this unnecessarily. And we also don't have any kind of background process going on that we have to manage. But there is a trade-off to this, of what this means is that if we kick this off here, if we do this like, where do we have our, I think it's if you've done something totally new now, let's see.
Oh, I just made it, I'm making it loop basically for forever. And actually I was going to just work it and do the trick of do the whole console.readline.
Nice, and then we just hit the button to turn it off, yeah. So the way we've got it set up now, either in the way it's actually implemented in Zio or in this example, is that if we start this cache thing here, and then we like, let's just say we take 10 seconds and we don't do anything, we're just doing other startup stuff, and then we start making calls, well, we're not going to get the token for the first time until we make that first call. And that means the first call is going to have to wait for the token. Now, the alternative for this is we could imagine what you could think of as more, you could call it like eager caching, or maybe you would call it like prefetching. But you could say, well, once we kick this off, we should just start some process that's always going to be asking for auth tokens on whatever frequency we need to and putting them somewhere. And that way, anyone who needs an auth token is just going to be able to get one, and hopefully is never going to have to wait for an auth token, because there should just always be a current auth token for them. So that would be a different approach. Now, that would have some downsides of its own, right? That would mean that if maybe a minute goes by and we're not making any requests from the Slack client, we're still, whatever, every 5 seconds, we're still paying the Slack client to get the latest authorization token. So that's not necessarily better or worse. And I mean, I would say probably for a library, actually, Zio has like the right default here of doing this lazily, but it's something that's worth thinking about for your own services if you're dealing with something like this of, especially getting going, just using the off-the-shelf cached operator may be the best thing, but that maybe it's something where you want to make a different trade-off in your own application.
Maybe we could add this get deadline version or something. But want to use the get deadline now?
Yeah, let's see how it works here.
Utilities.cached. Okay, so we would basically just replace this line. So instead of doing this, calling cached, we would say utilities.cached, and then basically give a function that gets the expiration out. That goes from our A to our instant. So it's quite easy in this case. And then let me hit enter to kill everything. By the way, okay, and then so what did we get back? Oh yeah, I just need to make this a, oh yeah, this should take any Zio, I guess, REA. I've kind of made this a little, I'll just make it as, I'll just hard code it down here. Zio Slack client, nothing, auth token. Let's do that. Is that happy now? Come on. So yeah, that should now work. But yeah, a little tip, if you want to like loop something and cancel it on demand in the terminal, mostly useful for us as Zymposium people, but it's also good fun for demos. You can fork something, and then if you wanted to like wait, you could just do console read lines. So the program will block until you just hit enter essentially. So that's quite nice.
Yeah, and that's actually also an example of automatic supervision here, right? Because if you had a different effect system that maybe didn't have that concept, like this could just keep running in the background forever, depending on how it's done. Versus with Zio, as soon as you get down here and this thing is done, then it automatically interrupts its child fibers.
And if we see what's happening now, it's doing even better, and that's because I extended the. A while ago, I extended the auth token expiration to 7 seconds. But before, when we had to sort of manually specify our cache time, we kept it at 4 seconds. So it was only able to make 2 posts before it had to refresh the token. But now it's actually based upon the real expiration. And I could probably do like minus seconds or whatever. I don't exactly know, but I could subtract. How do I do this? Is minus nanos, minus millis, 200 just to save any buffer So if we accidentally like hit just the right time where it's about to expire. So yeah, that's the nice thing about giving us control, and we could do that based on what we think our latency is going to be. So yeah, that's kind of nice.
Yeah. So I think, well, from here, one maybe we can just do a check on like questions, but then I think there are a couple of directions we potentially go here. Of one, we could explore that more like eager versus lazy distinction, and we could explore, like, we could call it either a eager caching or like a prefetching version of this. And that's one thing we could do. Or we could explore how we might implement this with one of these other data structures. Like maybe we could see, well, what if we do it with a normal ref and not the synchronized ref, and what else do we have to do here?
Okay, we did have a couple of questions. Oh, apparently there's something called Scala concurrent duration deadline that I guess can work. I'm not quite sure how to convert an instant. Maybe it's just like deadline or something. Deadline? I don't know exactly, but that's a cool data structure to explore. Thank you for the tip. Scala duration dot. Oh, concurrent duration deadline. Okay. Well, yes, I'll trust that. If anyone wants to look at that, yay. Sounds good. Then you don't have to compare it to now, which is nice. How would that work? I mean, you'd have to look at the current. It must like internally look at the clock. So that might be less testable. I mean, there's no way to just have a pure value that knows whether it's expired or not. So it must sort of be a RAPA call. I might not understand it. I'll look at that later though. And then
I think that's.
Naveed asked why. Naveed asked why no interrupt. I guess down here. I believe this is interrupting it. We're not seeing at least any more output. Is it just sort of interrupting it based on the scope of the program? Like why is this being interrupted? I could probably put a Zio dot on interrupts or on exits. Here, let me add a. Yeah, how can I do on interrupts? Where's that one? On interrupts. I'll wrap it around this whole loop thing. Fork.on interrupts, Zio. Let's see if it's being interrupted or not. Zio.debug help. Should I save it? Hey, so yeah, it's totally being interrupted. Why is that happening, Adam?
Yeah, so that was that point I was making earlier about automatic fiber supervision. So there's one parent fiber here that's running our main program, and then we're forking a child fiber here. And in Zio, with automatic interruption and supervision, when this parent fiber finishes its life, it's going to automatically interrupt all of its children. And so that's why this console.readline is sufficient itself. If we wanted to be like super explicit, we could have assigned, that thing to fiber, and down here we could have done fiber.interrupt. But with automatic supervision, those things are the same as long as we just fork this within the normal scope here.
Yep. Or we could have done the new fork scoped and put a Zio.scoped around this whole thing.
Right. Well, in fact, we wouldn't even need the Zio.scope because every Zio application has one scope that gets provided to it. That's the application scope.
I wonder if with the provide, though, I might need to do something there. Yeah, because it's going to want to scope now.
Oh, because you're because you're doing the provide. Yeah. This is saying you're providing everything. If you wanted to do provide some scope, then that would work.
Maybe I should add a provide scoped or something because we got rid of custom. But anyway, that's cool. Yeah, that's a nice little bonus thing. Help. But yeah, just fork is good. It would fork daemon then sort of. What have I done?
I think in this case, because we're shutting down the entire application, let's see.
Oops, I killed the utility. So cache token equals, where'd that go? Anyway, I'll get that back. Cache token equals. Oh, it's smart enough to almost do it right. So fork daemon. Yeah, let's see what happens. Always good to experiment. Oh, yep, it's still going. So yeah, don't fork a daemon. Was it killed eventually? Yeah, but it didn't get interrupted. So, or a demon. I don't know. Whatever you want to say. Cool. Yeah, I'd use the system nanotime, so you can't use test clock to test it. That would make
Yep.
sense to me. So probably
Yeah,
safer to do something. If
yeah,
yeah,
because they're just living in that world. Yeah, that's the more side affecting world.
yeah, definitely. I didn't know about it though, and how
Yeah,
I've
I
forgotten
know,
about
definitely. I feel like there's a lot of things in that like scale. I mean, partly it's just kind of what ecosystem you live in. I'm sure if you do future all the time, you learn about like all the things in there, and otherwise you kind of learn what you need to. And we learn a lot about all the Zio tricks we got.
it. But yeah, cool, and definitely this pattern of if we can go back up to the cached utilities, it's definitely one that's worth. If you're going to do more advanced things, you could solve some pretty cool problems with this. Basically, every time I see Adam opening up a fancy pull request that's doing something, there it some way involves modify and returns that tuple of a return value and updated state. And yeah, it's definitely something if you want to make safe concurrent things and make them easy. It's a cool trick to learn about. Because it makes it, we're doing something not too trivial here, and it's kind of just working. I mean, it would also work if we did this, I guess, in parallel as well. I could have done that. Didn't really, we didn't quite do that. Maybe we could. That should be easy, right? Zio dot for each par 1 to 10, and then we'll just loop in here, and then I'll fork all those guys. Let's see what that does. It's probably going to be a hectic disaster of messages. But look how many refresh tokens were sent. Only one, and it hasn't blown up, at least not yet. Yeah, and so everything was waiting on that refresh token, which is kind of cool. Yeah, let me like do a random sleep time as well. So sleep random dot next int between, let's do 1 and 3, and we'll do sleep dot seconds. Let's try that. So everything is now sort of unsynced, and I'd hope that still it only queries at once. So even though the messages are coming in at a crazy time, they should all sort of suddenly, one's expired, and then yeah, it kind of goes through. Anyway, seems to be working.
Yeah. Now, I mean, this is one of like, if this is really what your application looks like, this might push you to that like prefetching more being valuable, because unfortunately here, you're kind of incurring some latency here of you try to do these 10 things in parallel. One of them's got to go and compute it, and the other two can take the cache value, but they can't take the cache value until the first one's computed it. So all 10 of these requests have that like latency of you getting the token, versus you can imagine if we like had some other process that was responsible for like always updating the token, then this might be able to go faster.
Yeah, but I mean, it is pretty cool that they only have to wait when it's actually being refreshed. So that could be the semantics that you want in some situation.
Oh, 100%. And that's why it's the default. And yeah, the other thing I like about this the synchronized ref and this modify Zio is this is pretty straightforward and readable. I mean, to our kind of discussion before about STM and like how the STM is like, I mean, that's like the extreme of being like dead simple in a way of like, if you just understand like the basic STM concepts, it's almost very hard for you to just get wrong the implementation. Here, there's like a little bit of like, you got to understand like the modify and the fact that it returns this tuple, and like the modify Zio, let's do the Zio that returns the tuple. But if you get that, the rest of this was like, pretty straightforward, right? And we're like, okay, if we don't have a value, get the value. If we have a value, see if the value is valid. If it's valid, return it. If it's not, compute it. Like there wasn't a lot of other like low level mechanics we have to do, versus if we like went to like the ref and the promise, we'd have to be like doing a lot more of like, when do we create the promise, and are we fulfilling the promise, or are we the one who like has to wait for the promise? And we got to make sure, well, if we the one who's supposed to fulfill it, then we definitely can't get interrupted. And there's just a lot more to think about there. And that could give you definitely a more performant implementation. But there are a lot of cases where like this, where like the real performance gain you're going for is just you don't want to calculate the token all the time. Like and conceptually, you do need to wait until someone's calculated the token. So like having the most blazing fast possible, just like implementation of like doing this, like the mechanics of this update is probably not actually impacting your application. And this is going to be a lot faster for you to write and probably a lot less prone to bugs than kind of the ref version. So it's one of those things where like I think there's a real trade-off in like developer productivity that I think sometimes gets underappreciated. And I mean, there's definitely times where it's worth investing in having the super low level thing is efficient, but like decide whether that's really what you're being asked to do, or here like you're just supposed to like do something with a Slack service, and this just kind of needs to be like pretty efficient at doing that, and not necessarily like every like low level building block is like the lowest level could possibly be.
Yep, that's pretty good. Cool. Well, let me see. I mean, maybe, yeah. How would the other? Well, maybe we could take a look at that in a moment. Someone on the Discord, Artigo, asked if we could explore maybe something like Deadline, and I think that would just be so trivial to build, like a Zio version of Deadline. So maybe we could just build that really quickly, because that I think would take 30 seconds.
Is it almost this, or yeah? I mean, let's see.
Well,
I
if we
think
wanted to make it like a value, right? The Deadline, it
yeah.
really just would have inside of it an instant. Maybe that would be private. Maybe this wouldn't be a case class or something. It would maybe have def like is expired. Well, this
Right, and these now would be like UIOs, because they would use we would need to get the time.
Yeah, clock.instant dots map, and then is after Deadline, and that's kind of really it. And then you could just make one from an instant just like this and see if it's expired. And that would save us the step of basically doing what we did on line 92 if our deadline were one of these deadlines that we made from an instant, and we just get the Boolean back.
Yeah, and I think in a way that like illustrates maybe a little bit of a valuable design principle. That so if we go to that, like let's see if I can go back to that Scala dot, what was it, concurrent dot duration dot deadline, I think it was.
Mm-hmm.
Let's see if I can. Deadline. Yeah. Okay. So if we click through here, so I think one thing that can be helpful is like, I mean, maybe I actually think I will just like copy this. Maybe I'll put it down here. I'll just call this like object deadline example. Oops. And so one thing that can be pretty useful is anytime you have like a data structure or like an API from a third-party library, you can look at it and you can ask yourself a question of, are the operators in this, are they all doing things that are pure mathy things, or are they doing things that are like not mathy things? And so here, if I look at some of these and I scroll down to them, like, so this time left seems like, I mean, this is saying it like entails system call, check system.nanotime. So this is clearly like, this is actually not doing mathy things. This is doing side effects, is doing effects. This is doing what should be a Zio workflow. And so what you can do is like, if we said, well, this was the original deadline, you can do a kind of mechanical process of, you could just say, I mean, maybe I'm just at least for this, I'll play with we'll just put the Z in front of everything. But you can basically take every one of those methods and you can take its same signature and you can just put it into a Zio effect. So you could just say, well, this is, and we could ask ourselves a little bit like, can this fail or not? Like, should this be a UIO or should this be a task? But you can just make all of these things that are not pure mathy things just return Zio workflows. And then depending on what you want to do, this one's probably simple enough that we would implement it ourselves with like the clock service to be testable. But if it was something that had more like complex logic to it, we could also just do like Zio succeed. And depending on what we were doing, this could even have something like, this could have some like underlying, that's a Scala concurrent duration deadline, and we could even just call the method on the underlying. and just suspend it in a Zio effect. And if we were doing something that had more complex inner logic to it, if this was like a, the Java Kafka client or something, we're like, we don't want to be able to Kafka, we want to use their Kafka, then like this could be like a really good pattern. So, definitely nothing like that exciting here, but just to kind of illustrate that idea that anytime you've got any type of like third-party data structure interface, it's pretty easy to kind of convert it into an idiomatic Zio version of the same thing. And then as we saw, it gets a little bit nicer to use in your application, especially if you're using it in more places or more complex things than, in this case, we were just doing this one thing.
That's a great point. We got a couple of good questions. One from a little while ago, because I think this is because we've been talking about scopes and Zmanage in the past recently.
Yeah.
On the Zoom, we got a question. So I check the Zoom every once in a while, but definitely try to chat in the Discord if you can, if you want your answers or questions answered sooner. But this is a good question. So from Oleg, so Zio within another Zio looks like a pattern to avoid Zio.scoped or the old Zmanaged when you would need to allocate, right, ref synchronized with acquire resources. He says just a comment, but I think there is a subtle distinction, right? Do you want to?
Yeah, so I actually don't know if that's accurate because like cached here has exactly the same signature as in Zio 1 and previous version of Zio 2. So even when we had Zmanaged, it had exactly the same signature. And so I think, and maybe you were getting there and I'll hand it over to you for a sec, but there's a distinction between what you call effects and what you could maybe call resources that require finalization. So here, there's actually no finalization required here. So it's not an issue of Zmanaged or scopes, but there is just creation of mutable state essentially required here. So that's why this needs to be an effect. But maybe let me hand it over to you.
No, I think that's right. Is there a ref dot like destroy or something or shut down? I'm not sure if there is. I don't think there is.
No, there isn't because it just has this value. So you could change the value if you wanted. But yeah, there's not a concept of shutting down a ref, and
yeah,
that kind of makes it easier to use because scopes are great if you need them and if you have things that need to be scoped. But if you have something that doesn't need to be scoped, it's even easier if it doesn't require a scope at all.
Yeah, but that's exactly what I was going to say. Is that there is no scope, there is no finalization. It's not really a resource. You're just using an effect to generate another effect, and yeah, that kind of makes sense. Yeah, if you've used like JavaScript where there are no effect systems, there are a lot of libraries have something like cached. Like they have all these utility libraries called like Lodash and Ramda or underscore. For some reason, they're focused on the underscore, basically because they need a real standard library and they tuck it into the underscore character with and add a bunch of methods. So you'll get something like cached and you give it a function, you just get back another function, which is now a cached version of the original function. Of course, what they're doing internally is they're creating a closure and creating a var in there. It's just that they don't, it's not an effect system, so they don't have to sort of they can just create vars whenever. And yeah, but the nice thing about, and I guess technically we could have done that as well. We could have lied and added a var, but it wouldn't have had the same concurrent semantics that ref.synchronize gives you anyway, which are really nice. Like we could have like down below, we're like forking 10 parallel fibers, running 10 things in parallel, or concurrently and in parallel somewhat, depending on whatever your operating system threads, and looping in each of those. And they were all sending messages. And then the second the token expired, only once did we query for the API. Anyway, you guys all saw what happened, but that's pretty cool. And yeah, that wouldn't happen just in JavaScript. So nicely.
Yeah. Well, and the other issue there is preserving that referential transparency and our ability to reason about all of these programs in the same way. Because if this didn't return a Zio within a Zio like this, then what we could do is something like I would have like A in Zio.cached 4 seconds, and then B equals Zio.cached 4 seconds. And what functional programming would say I should always be able to do is, well, if these refer to the same thing, I should be able to extract them into another variable, and I should just be able to say like C equals zo.cached 4 seconds, and then replace both of these with C. But if we think about it, we would realize that like these are actually doing different things. That if I create one ZO cached and then these both just refer to it, then I'm essentially creating one cache, right? And they're all calling it the same thing. Versus if I'm doing this, I'm creating 2 different caches, and they're each calling into their respective cache. And so this would actually be violating those like referential transparency principles and basically kind of creating this like weird exception where like we would have to know that like we can't reason about cache the same way we can reason about the rest of our program. And there's just like, it's definitely not like worth to do that. Of there's like a little bit of, we might just like need to remember like, hey, we need to flat map this cache thing to get the cached version. But then we can reason about this the same way we reason about the rest of our program. And you know, we see this was actually pretty natural for us to do.
Oh yeah, right. Yes. Sorry, coming up with
No.
Yeah, now I forgot the actual name of it. Okay, cool. Sweet. Good property to have. Yeah. Oops. Just trying to. There we go. Yeah, great. I mean, it is 3:04. Maybe we can end soon. There are no more questions. However, how difficult would it be to do the one that's eagerly recalculates? Is that possible with a ref synchronized? Or would we have to do something more complicated with refs and promises? Would it maybe be worth looking at that problem another time?
We definitely could. I think that one could actually be done pretty easily, maybe with just a ref, because I think what we might do there is we might just say, well, let's calculate initial value, let's put it inside the ref, and let's fork a fiber. And the fiber's job is just going to be either every 10 seconds or every second before the deadline expires. It's just going to put a new value in the ref, and it's just going to run forever. And I think the only thing that's going to be like slightly fancy about that is I think we will want to use a scope for that one, because we're going to want to have some concept of the lifetime of that fiber. And we're going to want to say that whenever that scope is closed, we're going to interrupt that fiber.
Yep. So yeah, maybe we could do that, right? So maybe we can make our other method that gets it. Yeah. So how should we go about doing this?
Well, so maybe we should start by getting a initial one. So we might say, well, first let's just run this thing once to get an A, and then we can call this get deadline to get the deadline. And then we can just say state.value of the A and the deadline. And then we can make a ref that has the state in it. And then we're going to need to fork off this fiber.
At this point, actually, I think it could just be ref of A, because we're just going to
exactly. You're totally right. So yeah, you're right. I could get rid of this. And then we're going to need some fiber. And I think it might be helpful for us to create like a little bit of like another method that's just going to like describe the work of this fiber.
Yeah, let's say work.
And so this is probably going to maybe take probably the ref and the deadline.
Maybe we could even do it here.
Yeah, we could do it in line if we wanted. Yeah.
Oh, but I see we do want the deadline to change as we go along. So
yeah, and then we could define as an anonymous function, but yeah, I find it's sometimes easier if we.
Yeah, I like this deadline instance.
And so I think maybe this one we will want it to have some concept of the buffer potentially. I guess maybe it can be done the same way.
Yeah, it can still be the same way.
Yeah. So I think we'll say maybe the first thing we need to do is we need to get the current time here. And then we might say maybe duration. I think there's some like duration dot between, I think. Now and the deadline. And so we might sleep for the duration.
A sleep until might be nice.
Yeah.
Just thinking.
And then at that point, we could run the Zio workflow again.
Mm-hmm. Or we kind of have it down here, I think.
Yeah, so we'll get the A, and then we need to put that in the ref. And then we'll loop, yeah. And I think if we
Yep.
here, and then if we wanted to be really safe, probably if we're going to recurse forever with this, we don't want to do the for comprehension, but that's a very minor thing. And then this.
We could do deadline minus. No, between. Is there a between? I couldn't. There unfortunately wasn't a duration between. Duration dot. What do we got? Duration. Why? I do want between.
Well, also, these are like the Java durations. So I think there's some operator that we're just like not knowing the.
The one thing I don't like about Copilot is it takes over my autocomplete sometimes. I could disable it. There we go. Okay. Disable globally. What have we got here? Give me autocomplete. There we go. From interval. Oh, from interval, I believe. So start and end would be now and fresh deadline. Cool.
Right.
If that.
Yeah, let me get some autocomplete going here. That requires offset date times.
No.
Yeah, exactly.
Okay, wait. You know what? I'm gonna go full autocomplete. So or full GitHub Copilot. Get the duration. Get the instant. Get the duration between now and the deadline. Duration. Oh, until now. Now until deadline, I believe. Yeah, cool. And then that needs to be an instant, maybe. What is that? A long sleep dot long millis then.
Probably, yeah.
Aha! Thank you.
Okay.
Violet,
all right, awesome. And so now we're making progress here. So now we got, I guess, a couple things here. So one is we're kind of running this once the first time. So we just need to update our signature a little bit here, which I think actually is like honest, we could say, of like this first one could fail now. And then our final thing, this just needs to be ref.get here. And then this needs to be forked off into another fiber. And this is where this concept of scope might be useful, because the scope is going to let us describe the life of this fiber. And so now this could return an R with scope.
Yep. Aha.
And so this might be how we would approach it in more of that like eager way to do that. And so we see some of those like advantages and disadvantages of we're like starting doing this right now, which maybe we're never going to need this. Maybe we called this thing and never need it. So we're kind of doing that wastefully. This is, again, going to keep refreshing, even if maybe there's like no one who wants it in the next 10 seconds. But there's basically always going to be a value available here. At least, I mean, there'll be the initial startup time where we calculate the first time. But after that, there's always going to be a value available here. And we're able to take advantage of this scope to describe the lifetime of this fiber.
Want to run it down below?
Let's give it a shot. Let's see.
So I'm going to run main. So it had to get it the first time. Everything had to wait. But now, theoretically, it should start.
Yeah, see how it's just boom, boom, boom.
Yeah, so nothing is actually waiting on it anymore, and nothing's breaking either. So it's just getting it in there in between. Those dots are just showing up. So yeah, it's getting it a couple seconds before it's about to expire eagerly, so everything can make it. So a couple cool little options, both pretty trivial, both very useful depending on the semantics that you require, and like barely any code. It's also beautiful. Yeah, I mean, the one thing that could be interesting to get to in the future is, okay, so it introduces a scope. And because we're just kind of calling it here at the beginning of our application, it's not too hard to say provide some scope and let the default application scope take care of it. But if you want to embed this like in a service, a really nice way of basically doing that would be to get a scope from your, you can initialize a layer and pass that scope down into your implementation. So you can use the scope of your entire layer to run that process, which is really nice. So then when people are calling these methods, they kind of don't even need to know about the scope. It's handled in terms of the initialization of the whole layer. Maybe that would be worth a follow-up in the future.
Yeah, yeah. You can use that zlayer.scoped operator to like convert any scope ZO into a layer. And yeah, I think that's really nice for background processes because in ZO1, a lot of times you do like fork daemon for that background process, which was great because it wouldn't get interrupted too early, but meant that it would kind of live forever. Versus this way, it won't get interrupted too early, but it'll have this kind of life that's scoped the life of the layer. And even like in ZO itself, we're using that for some things like we've got some of these layers that set up metrics collections and set up sending these metrics to various services at some frequency. And so the layer will essentially do one of these like fork scope things where we'll fork a fiber that will just keep doing that. And the life of that fiber is governed by the life of the layer. So if you're doing this, you're providing that metrics layer to your whole application, then it'll last your whole application. But if you're providing the metrics layer to some part of your application, then it'll last for the life of that part of that application. You have a guarantee that's going to get shut down appropriately when that's done and all that good stuff.
Maybe just because, and since maybe we could go to we got 15 more minutes left. So maybe it actually would be worth showing that off since we're here.
Yeah.
So I'm going to just make a client that would represent maybe a wrapper for, we had that server, but now we want to make a cached interface to that server so that in our code, we just have this Slack client and we just give it the interface of send message. So this doesn't even need to know about the auth token at all. That would be set up because it's kind of annoying. That would be set up at the top of your application potentially. So what we need to do here is get our token, and then we can call our Slack client and have that post the message with the token. So that's all the implementation would have to do. Oops, excuse me. Why is it sad? Slack client. Oops. Cached Slack client. Let's do that. So they already called the other one that, and this has to be an auth token. Great, and I don't think that can fail, but whatever, it's okay. And then now we're going to make a layer for this where all the sort of the logic is going to take place. So we'll say val live, and here we can say for yield. Cool. So we're going to want to get our cached operation here, cached operation. So we're going to take the Slack client, call refresh token, and get the expiration -2 seconds. And I guess we can get our client as well, the other client, by calling zo.service Slack client. So this is the initial one. So here I can just call client.refresh token, and then we can instantiate our cached Slack client with the cached token and the client itself. And then we just basically wrap this thing in zlayer.scoped, which let's see, can you fill in the type of what this is currently?
Yeah, let's see if I can. Yep.
Why doesn't it have that should add the scope, right? It just might be wrong, I guess. But yeah, because it is sad.
Yeah,
I think it's because I didn't save it. Maybe, yeah, so technically it should be with scope. Yeah, because this adds the scope. But we don't really want to deal with the scope. And also we want a layer. So that's the whole point of zlayer. So if you do zlayer.scoped, what this will do is it will translate it into a Z layer. And it'll also take care of the scope for you. So this will now just need a Slack client and get us back our cached Slack client. And then here I can say def send message equals zo.service with zo and send a message strings. Now we no longer have to worry about that token at all, and we get this accessor. So now if we go down here, because provide some scope isn't very fun, and because this could be like deep in our application, we can make another service that depends on cache Slack client, just as we depend on Slack client in this service. So let's go down here, and instead of saying this utilities thing, whatever, we'll just get rid of all of this. We'll change these uses to cached oops, these two uses too. Vim is not being very happy. I'll just type it normally. Cache Slack client. I'll say cached Slack client dot post message. I'll get rid of the token stuff. I love not having a token to worry about. And then down here, oh yeah, we don't even need this. We don't need to. You need to simplify this dramatically. So it's just a loop. Oh, thank you. So this just becomes loop now. Great. And then now we just get that nice error saying that, hey, we need to provide a cached Slack client. So if I do cached Slack client live and save it, I know this isn't going to work, but just so we get the fancy error message, now we need a Slack client for the cached Slack client because it depends on internet service. So I save this again, and now it should just hopefully work, and it compiles. And so now if we do run main again, it should work just the same, except as a user, here on like 162, we don't have to worry about any of that. And the layers completely encapsulate the creating of these background processes that are managed appropriately in scopes that have repeating tasks that can do any sort of thing. And that's going to be managed, and it's going to be shut down appropriately when the scope of this layer exits, which happens to be our outer scope for the whole application, but it doesn't necessarily have to be. And that kind of, I don't know, that's like, this is the stuff about Zio that just like, I don't think there's any other platform out there that allows this kind of compositionality. Or like, yeah, people sometimes make fun of like, oh, dependency injection, it's just passing parameters to functions.
Just functions.
It's like, it's so funny that like, that's the one area where functional programmers decide it's not worth making like a proper functional domain and really thinking about the problems that exist there. And I don't know, I think there are problems that exist there, and there are so many ways to get it wrong and so much annoyance in the real world, but it really lets you, like if we go to the live definition of cached Slack client, this layer really describes this entire complicated, resourceful acquisition of running some process in the background and requiring and other things, and everything is scoped just here. Like it's totally decoupled from the rest of the application. So anyway, I'm pro Zio. I hope that seems cool to other people as well. Yeah. And now it's yeah, cool. Let's see if there are any questions. Yeah, okay, this is amazing, good stuff. All right, some people agree.
Yeah, no, this is great.
Copilot is amazing. I agree, Tobias.
Yeah, that's true too.
Yeah,
All
it's there. It's great for
Awesome.
navigating Java APIs. It's probably so good at Java too, because there's so much Java code out there.
So much of it, yeah, that's a good point.
But yeah, everyone's got to start using Zio too, so we can, and pushing open source code. So
it gets better and better.
Old style autocomplete. Okay, we got a couple people typing, but I think if there are no other big questions, that might be the end, but I will allow the typing to complete.
I think this is great.
Need a book on Zio too. It's too amazing. I think
it is in the works. As soon as we just want to make sure Zio 2 is as good as it can possibly be first, because we're going to have that for hopefully a couple of years.
I think
that's it. Build all sorts of other cool stuff on top of it.
Yeah. All right, guys. Well, I'll stop having this token thing run, and bye everyone. Bye friends, and see you next Friday.